living without exceptions. So every time I start a new app, I always I put my mental hat on and I imagine my project look like this. Like you just got this nice new car, then it's like you start coding on it. You get into like the groove, just banging on the keyboard, and it's like you follow the motto of move fast and have breakfast during the time, because breakfast is the most important food of the day. And slowly your application starts devolving into something that it's still recognizable, but you see some patches here and there, and you're like, what the hell just happened to me here? I don't know. And that's the thing with the exceptions. They're like really cute bunnies that just cover your application, and at some point they suffocate you. People talk about that you can actually, in Sweden, you cannot have eat a rabbit or something, I don't know. So yeah, you get to screens like this, very famous color scheme. So yeah, today we are going to talk about how to live without those things, without the exceptions. So my name is RADOSLAV STANKOV. I come from Bulgaria, this country which has the Windows error color on the screen. I write a newsletter called Tips, and right now I'm the CTO and co-founder of a startup called Angry Building, and I very much hope to rename the company Happy Building at some point when we accomplished our mission. I used to be the CTO of Product Hunt, and I'm going to share a lot of tips from those two companies. So I'm going to show a lot of code. I like having a lot of code, and I uploaded my code here because often I notice people just taking photos, and I speak too fast, I present too fast, so yeah, all the slides are already uploaded here. You can see all the code, you can see basically everything. So when I started at Product Hunt, we were just 4 developers, the company, and we figured out having errors in our application is not, nobody wants errors, but we particularly wanted to have a process around them. So we have this internal process called Happy Friday when we were 4 developers. When the company grew to 8 developers, we developed another process called the Strike Team, which was basically the junior developers who were responsible to fix exceptions. And the Strike Team at some point became more senior. And when the company became more than 20 engineers, we introduced something called the Bug Duty, which was a dedicated sprint where 1 or 2 engineers were actually responsible for fixing bugs, fixing exceptions, and handling all of that. At my current company, I'm the only developer, so I only do Happy Fridays. I don't do Strike Teams because it's a team of 1. And for me, the Happy Friday was a very good way of a hack, kind of, to do a lot of things. Happy Friday process was, what you do Friday is you basically work 4 days, and your Friday you can work on one of those 5 things, which is fix bugs, fix exceptions, bump dependencies, keeping up to them, pay some technical debt, we have something that's not very well designed, or catch up on projects. Sometimes people just catch up on projects, but the idea of the Friday is you think about your sprint 2 weeks, but not 5 days each week, but 4 days each week, and then you can actually do some catch up. But what I used to do is just go and fix exceptions. This was, if you search in GitHub, you just see all those PRs at 135, just going and fixing exceptions left and right. But the key here is, the first takeaway is, if you want to have a clean system from exception point of view, you should have some process. You should have an explicit process who, when, what are fixing those exceptions. Because if nobody is the owner, or everybody is an owner, they will just pile up, and pile up. Another thing when working with exceptions is there is this wonderful book. It's a bit old, but actually the Ruby exception system is very well designed from the start. So this book actually teaches us a lot of good tricks about how the Ruby exceptions are being handled, how you can actually build things around it. So the first thing you do is, okay, I have this code, and it raises some error. It does something, it raises some error, and you just do one rescue, and you are fine. You can never get an error from this. And You shouldn't do that. Like the problem with something like this is you are painting yourself in a corner. Like at some point your application will start behaving weirdly and you won't be able to find out why is this happening. Stuff like this happens. Like this one if is coding your application and at some point everything is going to crumble down. So something a bit better here is you can do, okay, I'm handling this specific error. It's a bit better because you just have something specific. It's also useful to just say, okay, I'm explicitly returning null because maybe I'm returning some error or something. You add a comment, why do I return null here? Like, why is this acceptable to my application? And the comment should be just, Radu told me so. It should be like, okay, in this case, the network service is unreliable and it's fine to do yada, yada, yada. Also, when I say specific error, I mean, for example, here like this. Like, if you call a service that you know it often times out, it's fine to say, okay, the timeout, it's error, it sucks, and it works. Like, the idea here is you want with errors, especially you want to be very explicit. You should be able to handle the specific errors. You should know what's happening here. Sometimes when handling errors, for example, you want to say, oh, this thing returns null, but I'm actually logging it into my error tracker, so I actually know it for later, but my customers don't see it. Another thing when we talk about error is monitoring. Like, how do we make sure our applications have exceptions? Like, if we don't have any monitoring, that means we don't have any exceptions. Everything is great. But our customers are not that happy. So I actually like to have Sentry, like that. This is the tool we use for like the last decade. And it's very good because you can just, if you have like more big application, you can actually make use Sentry for all of that. So one thing as a trick which I do is I'm having multiple Sentry projects for all my different tools. Like for example, for Rails, I usually have at least 2 projects in Sentry, which is production web, production sidekick. Like the idea there is, if you get an error on the web, which is like during the web request, those exceptions have different characteristics than the errors coming from like a sidekick. Like the sidekick ones, you can actually delay fixing them because they're being replayed. Often you see a lot of escalations in sidekick errors, but it's just because one job is failing and not like 200 million requests. So another tip is here is, when you set up your monitoring, it's useful to group your error or to group your exceptions into buckets, and those buckets would be specific to the different uses. Like another example is at Product we used to have a public API. And exceptions from the public API, they go to their own sidekick Sentry project. And those have different reasons how we fix that, depending different than the main web application or the sidekick. And all of those can have different escalation levels. Because one problem when we're dealing with exception is having too many of them and don't know where to start fixing them. Another useful thing is I always set up this channel in Slack, or if you use Team, just having them in Teams. But the idea there is like, you have a Slack channel. Every time you do a deploy, you should post a message, oh, I deployed. And then in the same channel, you start receiving the new exceptions in your system. So this is very useful for example, I just deployed, and at some point, I start seeing like a lot of new exceptions. Where do those come from? Is it just a coincidence, or is my code buggy now? And this is a very useful way for you to kind of triage those. Something that what I used to do when I have a team was, okay, somebody deploys, you see exceptions, and actually the discussions about those exceptions happens in Slack. And I can see, and people use the emojis to react to, oh, I'm handling this error, or I don't know who is this error. And it's very useful for you to see the flood of new exceptions, because what I have found out is the longer an exception has been in your system, the harder it is to fix. Like usually if you deploy and I see those 2 errors, it's very easy for me to point out, oh, maybe that's the deploy that broke those exceptions. It's not always true, but in most cases I have found out the new code tends to start raising new exceptions. So this is another tip I want to show you. It's like have like a Slack channel where you actually merge when you log both the new exceptions and all the deploys, so you actually can correlate because of that. It's a very useful thing to do. Also, there is, I like this quote from Ken Cunningham and Ron Pike from Practice of Programming, like a very old book, where the idea there is that exceptions are for exceptional situations. They're for things that they shouldn't be used for fault control. It's stuff that we can expect. And a lot of the times in our applications, when we set up error tracking, at some point we get a flood of things like this. Request timeout, routing error, like stuff that's not something we can do much about. Like technically we want to know if there is spike in those events. So having something like, for example, in Nurex IPM, we still log those, but I don't log this in Sentry because it's too much noise. So a lot of exceptions, I don't care about them, especially the exception called sidekick shutdown. Like that's the exception you get when sidekick's shutting down gracefully. And the idea here is you don't want this in your exception tracker. So having like, the idea here is you want to reduce the noise. Like one problem is you open like a Sentry project and you see like, oh man, 200 exceptions. Where should I start? Which is the most important? What's happening here? Compared to like opening Sentry and you see 5 exceptions. And it's like, okay, I kind of know what this is. So you should focus on like reducing noise, like handling things that kind of are exceptional. But you should also be very careful because you can get to situations like this where you hide too many exceptions and you are like, okay, I'm just going to hide this noise. I would save you here, and yeah. So you can get in situations like that, and you should be very careful. Like it's a tricky thing to avoid stuff. Let's talk a bit about like code. Like, I mean, we're developers. I like to show code. Funny GIFs and cats are nice, but we want to see code. How many of you have seen this exception before? Yeah, I really hated that. So when I see it, and I was like, how should I fix it? This was me on a Friday, like, oh man, it's this one again. So yeah, the thing about it is, I have this rule, like, I should be calm and just read the error message of this error. And if I have no idea how to do this error, I just Google it. Nowadays, I just ask ChatGPT to tell me the fix, but back in the day, I was Googling it. And this is kind of the fix of this error. Like, I found this in a ThoughtBot post about how to fix this error. You just need to convert and encode the UTF of the string in a way. And I have this exception code here. And since during my coding, I always have a lot of like things like that, like this bag of things that handle the exceptions for my applications, and they're very specific. Like the things I have in Angry Building and the things I have in Product Hunt were slightly different, and that's, I always namespace everything that handles things in my exceptions, just I name them handle, just because I like to have everything in namespace and not spread out across my system. So I always group those things in something called handle. Somebody else might call this error handlers or whatever. I just like handle. Sounds fun. I'm not very good at naming, by the way. Another thing where you can see, I can imagine many of you have seen this error here. It's like this error, or just a second. Yeah, this error over here. Like we have this method status null. Like this is again a very common error. And oops, wrong button here. So, and if we check the error, it's like, okay, we have this account subscription data status being called. And this is a very common error. This is something that happens very often. Again, we are calm. We just see the error message. We see this code here. And we just add this, and we are fine. Everything is great here. I love this feature of Ruby. It's great. It solves the problem. Kind of. It's something that where it's very simple to fix errors like this. The problem is why we have accounts without subscriptions. Like there might be a deeper problem here. Like I have found a bug where by mistake we deleted a subscription when you deleted a team member because of Rails auto-deleting functionality. One can speculate I have seen a bug like this in production someday. So the idea here is in situations like that, again, we should first honestly check why there is account without subscription. How many of those accounts are in the system? Then we should find out why. We should spend time to figure out, okay, why does this thing happen? And again, we should fix this. Again, I had a situation where you were able to delete the account of the subscription record of an account because there was a Rails connection to a team member, and when this team member who was the owner of the account was deleted, there was a scaling delete. It's too common of a bug because this company changed their manager and the manager who created the account and so on and so forth. And it's okay, who thought of that? The fix was a bit harder than this. And yeah, and again, we need to add the missing subscriptions to the account that are already broken. In my case, this was one account. So this was the first time this error happened to me, which was great because honestly, this could have happened to a lot more. And if I could have just ignored that situation, this error would have accumulated over and over and over again. And that's not very good. And then, when I did all that research for this simple one symbol fix, I can mark this as finished and done. And I can say, okay, great, let's go to the next thing. And again, this is the idea. You shouldn't never hide the exception. Sometimes, again, it's fine to say, oh, if this is null, ignore it, because there is a business valid reason why the null is in our system. I could argue that you should try to have less nulls, but the idea there is you should start digging through a system. This particular error is something where if I have just ignored that, in 2 months, half of my paying customers wouldn't have subscriptions which are connected to their Strap subscription, so I basically lose money. And I love money. They make me live. I live because of money, because otherwise I cannot buy food and eat. So this wouldn't be very good. So another example here is often I do things like that in my situation, where there is, for example, you can change for ship subscription on an account, and it can be blank, and you call this code. And maybe this is gated by a UI, maybe this is something. You don't want the user to see 500. You want to show the user an error. So I return to the user no subscription. And this is an error that the user can see. But then I use this, I have this module called error reporting. And my error reporting still reports this to my Sentry, and it says, okay, you now have seen this error. And this error shouldn't be here. So the user doesn't see the error, but you are notified about that. So then I can start doing my investigation and ask, okay, how does this user get here? And this is still a count as subscriptions. Those are two separate systems. But the story here was we have this in Product Hunt, we had this product ship, and the users can subscribe to ship. And at some point, we had a button in a pop-up that actually can do some actions on top of that subscription, but the user didn't have the subscription, so we didn't have the front-end UI validation. And having this code here was very useful for us to debug this elsewhere. And I use this technique quite a lot. I'm catching the exception, maybe some network timeout or something like that, and the user doesn't see an error. The user is fine, but I log this to my error reporting. And again, my error reporting module is very simple. It just delegates to Sentry, but it has some logic. For example, during testing, if I am in testing environment, instead of logging the exceptions, I just raise an error. If I'm development and I still hit that, I also raise an error. In production, it logs. And it's a very useful thing to have buckets. This is not specific to error handling, but what I like to have in my project is places where I can put bag of methods. For example, having a module named error reporting. it's a very nice thing because I can put all the stuff I care about error reporting there. I don't have to think about it. And later, if I remember all my slides correctly, you would see how else I'm using the error stuff. So let's talk about GraphQL. So I really like GraphQL. I use it in a lot of projects. I still haven't regretted it 6 years later. So either I'm delusional or actually this works, or maybe both. So one thing with GraphQL is like, how do you debug it? So you see this thing here, and you see, oh, no method error. Like there is undefined method value, null class, and the stack trace looks blurred out just because actually I did this for the presentation, doesn't look like that for real. So when you scroll down and you see, oh, there is this href, href, whatever, very complex looking thingy, and you're like, okay, GraphQL has one controller, it has one entry point, and there is an error summoning that point, which is the query that triggers that. Like this is very common thing with GraphQL because in normal Rails and REST, we have controller for every endpoint, and it's very easy to see, oh, the user's controller, the product controller, this is the thing that blows up. But with GraphQL, you have one controller. So a lot of the times when we started using GraphQL, we had these issues like, what was the query that causes this? Like, why is this there? Why are we on this earth? Like, when you get to those questions, you start questioning your fundamentals. So there is a bag of code here. I'm just highlighting some stuff. So this is the GraphQL controller, what we have. And here it's like, okay, we just get the GraphQL schema, we execute it. So one thing we do here is first, the GraphQL controller needs to authenticate the user. So when we authenticate the user, I'm using this error reporting, which I told you was just a bag of methods, to assign the user to the error reporting context. So if there is an exception during this user's request, Sentry, why everything is called starting with this, so confusing. If you get Sentry, in the Sentry error, you're going to see, oh, this error happened to this user. And that's very useful. Because a lot of the times I have seen, oh, there is a spike of errors. And those errors come from this user, whose username is security researcher 72. Why is this happening? And I got this message once from a security researcher where I noticed exceptions, and I noticed this username had security researcher something there. And I saw this exception he was throwing, so I found out, oh, this is a security researcher. Let me fix all of this stuff before he reports it to me. And at some point, I got a security report of like, oh, I found those issues, but they were fixed before I actually send this to you. Does this still count? So this is very useful to kind of attach the user to that. Also, a lot of times I have seen errors with some admins, because admins can have access to everything, and sometimes they have access to things that logically don't exist. And for example, an admin can have access to a premium feature, but the admin doesn't have a premium account, and they see some errors there. So it's useful to have that. This big, fat code stuff is also very useful. It's called handle error. So what we do is if the GraphQL query raises an error, we are handling this error. If it's development, we print a big log of the whole thing. In the console, we return 500. The same thing happens in test, but also in test, we are re-raising the error. And if it's development, if it's like production, what we do here is we do the capturing error and we add the query, the GraphQL query, to the sidekick. Like if we have this query, then in Sentry, when we see the error, we actually see which is the GraphQL query, the full GraphQL query that caused that issue. And this a lot of times is helping us go to the correct page, go to the correct info, and being able to debug that. And here you can add a lot more context. Like you can, for example, at what were the variables passed to that. Like you can do a lot of things here. For us, most of the time I have found just having the query is good enough. But the thing I want to tell here is not just how to debug GraphQL and how to track security researchers and fix the problems before they report it. It's useful to invest to make your system traceable, like to know where errors are coming from, decorate the errors with like extra information. So when they happen, you can trace the step back and you can actually open the thing and see how it goes. Like for me, having to spend 3 years every Friday fixing exceptions, usually what I started doing after the week 2 was like, okay, I fixed that. How can I make this easier to debug? What information, if I had, would have made my life easier? That's, for example, the moment where I added like this gem audited, where I actually see database changes, so I can see, oh, this user changed this here and here, just making the system easier to debug. Another bag of tips I want to do is around Sidekick or Active Job, or basically every other background worker. This would work for SolidQ most of the time. So I already mentioned this, but I cannot stress this enough how useful it is that your background jobs should be logged into a separate project than your main app. Because the way Active Job works and Sidekick works is if a job gets an exception, the job gets requeued again for 1 minute later, 2 minutes later, 10 minutes, and it has like exponential algorithm to how to schedule the job. So it's very easy, one job that fails, to report like, oh, we had 300 failures of this job, and this job is escalating. It's very hard, it's very easy for you to go and just debug one single job when there is a production endpoint field in GraphQL that's failing for half of your users. It's very easy to happen for that. So it's very useful to split your Sidekick projects. Another thing when you need to think about is often in my application I have this flow. I have a user action. The user does something. Then let's say I schedule a job that's, I mean, it's not very readable, just the yellow one, but this is like achievements job. And the user does something and we want to calculate achievements of this user. So we say, okay, achievement job, trigger it, and then we call this achievement and we create a unique achievement for the user. And that's nice. Like, it's a heavy process, it does a lot of things, but imagine, and this is the code. I don't love it, but yeah, it's a simple code. You have a background job, it does something else, that's fine. But if you have a situation where a user performs an action, another action in a quick succession, and those jobs are slow, they can be scheduled. And if, I don't know, this text is not very readable, this is a unique, you can only get one achievement for an action. So you can get this error here because this achievement already exists. And you as good developers most probably in the beginning of the achievement code have checked, oh, does this thing exist? If it exists, ignore it. So Sidekick would fail and with exceptions, then it would reschedule the job would run again, it would execute correctly, and you just have noise in your background jobs. So if you go back to the code here, I created something, I call it handle raise condition. So the idea of this handle raise condition code is it's quick and dirty. I mean, it wasn't quick, I did it for months tuning it to work, but it works something like this. It's yelling a block, and if it gets some of the active record code, it retries once. If it gets like record invalid with unique active record, it raises this again. So it basically replaces the code without logging it to the system. If this error happens more than like 2 times, it's okay, that's a valid error, we should continue. It works quite well. Rails have this new method where, you know how Rails have that find or create? Now they actually have create or find. Sometimes you cannot use create or find. Like, if you use create or find, it's great, but sometimes you can't, and that's the reason I have this handle raise condition. And I use it in a lot of times where I need to have like a unique constraint in my database, and I want this code to just rerun it a couple of times. It have removed a lot of noise in my errors. Another thing which I have seen quite a bit is most of the time you don't want to do network calls in the user request. Usually you do those in a background job, like sending notifications. So you have this deliver notification job, and then you notice, how many of you have seen that? Like, this is very often happening. So you see this, and it's like, okay, I cannot do much about it. The job would go into reschedule anyways. After like 50 tries, it's going to work. Why are you telling me about it? So you can do this, having this code, and you can just do this. And that's work, right? This is great. Fixes the job. It just retries the job. Retries jobs, just reschedule it. That's cool. Life is good. And then you see this one. And then you start seeing this one. And you're like, really? Seriously? I thought I did my job here. So you're like, okay, I'm adding it. Also, I'm adding this one. Timeout error. For some reason, it's good to be there. And I am adding another one and another one and another one. So I started doing this a couple of weeks in a row, and I get pissed off. And I was like, okay, I will do this. I'm going to get all the network possible errors here in this list. I'm going to make this triple equals. And you will see a nice Ruby trick in the moment. Like this. Features like this show how well Ruby is designed like a language. So having triple equals with error, so when you do error handling and you say rescue and you put the class on one side, or whatever you put on one side, it calls its triple equal methods with the error exception. So basically, I can do this. I can do handle network errors here, just like a normal exception, and Ruby is smart enough to call this method, which will check all my errors here. And it's wonderful. Like, this is the trick I learned from the Avdi book. It's really cool. So you just can handle all the network exceptions I can ever dream of and have this here. But then again, there is this other cool feature where you can just say, retrieve on all these network errors, wait 2 minutes, and have 5 attempts maybe. Actually, I put it to like 100 attempts. But that's also kind of work. And the thing about it is, if it fails after those 5 attempts, it's going to log. Maybe that service is in a really, really, really bad state. And having to copy-paste this code, and every time I have to decide 2 minutes, 5 minutes, 10 on 10, what I do is I create my handle job network errors, and I just put it here. And it's simple. You can just put it here. I'm very tempted to put it in application job, but just in case, I prefer to pick a job by job, just in case. And yeah, the code here is again very simple. It's job retry on. Also, if the job gets discarded, I use my error reporting here, because if this thing fails 50 times, I'm losing the job. If I lose the job, I might lose valuable information. I didn't know that, so I might have to lose some jobs at some point. Speculatively, of course, most probably not. But I have this error reporting job discarded method, which it gets a job, it gets exceptions, and it logs it in Sentry. So actually, if I get an error with Sentry, which is network related, I know there is like a serious problem with the service. I used to have this with Twitter quite a bit in the last year. I don't know why. So yeah, this is the code here. Also, I have this tweet of like, I have this theory that in every Rails project, we basically include every popular and unpopular network gem in the whole world. Like, basically, we have Fargate, REST client, Faraday, and pretty much. So in my error networks, I just list everything just because it's there. Like, surprisingly, every project I have worked for the last 3 years includes every network library in the world in my app. I don't know why. And yeah, stuff works. And this is how, again, a big chunk of the work is handling the network errors. One thing to notice here, for example, I don't handle errors which say authorization is broken, authentication is broken, because that's usually mean your authentication token is not there. So I don't handle those automatically here. Another thing I have seen as an error is this active job deserialization error. Hopefully from Rails 7.1 I would see this less and less. So this error happens where you have like a transaction and there is like some stuff that's inserting records in the database, and then you schedule a background job. And this background job is executed before the transaction is committed, and you get into a situation where the record you try to update is still not in the database itself. So Rails actually fixed this in 7.1, I think, or 7.0, where if you schedule an active job, then it would schedule the job after a transaction is committed, if the job is during a transaction period. So they added code to save us from that. But if you use Sidekick naked, like a lot of people say, oh, active jobs add so much stuff on top of me, I will just use Sidekick or whatever library directly. You can get to a situation where the records is still not in the database. And it's one of those errors where it's just noise. You see this error, but you see all those jobs are executed, it's just there. So the way to handle this is you can just say, usually I put this in application job, handle the serialization error, and the way you handle the serialization error is you just retry in a minute or like 50 seconds and you try it 2 times. If it doesn't work, then you actually log the error as a real error because this shouldn't have happened. And yeah, the idea here is you should create tooling around the common errors you see in your applications. Like the ones I show you, I think are quite general. I have a lot of specific tooling to my particular needs. Like for example, in my current startup, I send a lot of SMSs and I receive messages that the phones are invalid, that whatever. Then I have a whole process in my application, which is a business logic level, but because I have very low noises of exception, I can treat every exception quite gracefully. So yeah, the idea here is like, if you have this in your project long enough, every new exception is like an event. It's like, oh wow, something blew up, that's so exciting now. You're not that angry anymore. And you can invest a lot of time in the serious stuff. Because when we used to have a lot of exceptions, like when we started the Happy Friday, we used to have like 400 exceptions. And I was like, what should I fix? And what I was doing was, if you have a lot of things that are blowing up, but they're not that critical. If they were critical, they would be all hands on board. Like there's just stuff happening there. Like if there is a critical issue or on a bug, it's a red flag. People would know about it. So I was like, okay, I see 400. I would start just fixing the most easy ones. So I would be fixing like 50 exceptions because they're like so simple. Yeah, there were like 1 or 2 occurrences, but I just removed the noise. Like the idea there was, usually when I prioritize exceptions or even bugs, I'm thinking about the terms of, if it's priority 0, it's like a big problem, it's obvious that you should work on that. Like, it's so obvious. Like, if something is burning, if your system is down. But most of the things are not like that. Then, what I usually do is I just pick the easiest thing on the list. And when I pick the easiest thing, the next thing that's left is the next easiest thing. And in the end, it's just the hard things left. But there is no noise. Like, you can just slowly go to the list and fix all the things. And in the end, yeah, I have like things that will take me 2 days, 3 days, even a whole week. But I know who they are. I have already done the research for them, and I can actually put them as a scheduled project. Like at my startup right now, I have an issue like that. There is this one exception, which is a problem with the structural way we do some things, which I'm going to spend a whole sprint of work to restructure the system to make errors like this impossible. But I did it because I knew how hard this is, and I have a low level of noise. And the idea here is like, again, if our system is very clean, we can get to the mud again and start doing the fun stuff. And we can adjust our stuff. So yeah, that's basically the things I wanted to share with you today. It's like, you want to be very explicit. You don't want to hide stuff. You want to reduce the noise. Every exception should be exceptional in a bad way. You should never hide exception. You should invest in monitoring and internal tools. I actually have a whole post which expand to that because I only had 40 minutes here. And yeah, thank you for your attention.
Thank you.
And that's all for me. The slides are over here.